One of the questions in workshop 3 this morning was an essay question, and I'm sorry that I forgot to make sure that the homework set was actually open when you were answering that essay question. So hopefully you tried it, and even if you only got a check answers button and not a submit answers button, you at least got to see how it works. So just to remind you, this is what the essay question was. And if we go back to the homework set page, you'll notice that over in the right here we got a grade problem link. And if we follow that, down below we'll see, some people have answered this false. I'm not going to take the time to actually read this answer for correctness, but let's suppose that I thought it was 100% correct. I could just choose the mark correct option. Down here, David, certainly he got it correct. But suppose that I didn't like this particular answer, which I'm not actually reading and evaluating, and I thought, maybe I'll give them 60% on that. I could choose that over here. I could also provide them feedback on, something specific related to their answer. And then when I'm done with all of that, there it is at the bottom, there's a save button. Okay, and you can save multiple times, so you can grade a chunk of these and then come back and grade them fully later. Okay, so that's how the manual grading works for the essay questions.
I just wanted to point out that students can actually enter mathematics in their results, in their essays, using backticks, and that uses the typeset context where they can actually type in some mathematics.
Okay, yeah, so it looks like you've typeset this and it's being rendered using MathJax. You've typeset that as well. Very nice. Okay. Now on to this afternoon's question. So the breakout exercise that you had, one of them was to draw a parabola and have students enter the coordinates for the vertex of the parabola. And I have provided a solution here, and I'll take just a second to go over that solution. Okay, so the changes that I needed to make were to increase the window size, and notice that if I want edge or grid coordinates, I'll need to specify a range of 20 to 20 for the x and the y, and I'll need to change the labels to be between -10 and 10, and increase the domain of the function, and we had to modify the function as well to be randomized with some random parameters a and b, which I chose to be non-zero random values. And then the answer should be a point object. And I gave students an answer format help link, which we'll talk about briefly in a few minutes, telling them that they should, in fact, enter an answer that's a point, and it gives them some help page documentation on that as well. And then the one thing that you probably didn't think of off the top of your head was changing the context from numeric to point, so that when the student types in the answer as a point with parentheses, those parentheses will get interpreted as denoting a point rather than something else like an interval or whatever. Okay, so here's an example of a problem that is a matching problem where you have more possible answers than questions. And it uses the old-style answer checkers and answer constructors. And I think somebody has their mic on. I'm hearing breathing. That's not necessary. Thank you. And just like this morning, we're going to construct a new object and then populate it with some answer possibilities. And we're going to say to use the pop-up lists rather than having students enter strings that they type. Then we will populate that object with some questions and answers and choose some number of them to be displayed. We could choose, I guess there are 6 parts to this question-answer thing, so we could choose up to 6. And we can also include some extra answers and choose from among them. And other than that, the setup and everything is basically the same as before. There's one new wrinkle, though. With a matching problem, it's nice to have it in a 2-column format. And so if you load the PG union macros or the union tables macro file, you'll get a method for nicely plotting a 2-column table for matching problems. So it's specifically designed so we can just pass it this matching list object, and it will do all the rest of the formatting for us. And of course, that is being done in Perl mode. And as before, as this morning, we had a choice of what sort of graders we wanted. Maybe we wanted students to not get any credit until all the answers were correct using the standard problem grader, or using an incremental problem grader where they get 30, 60, or 100% correct, depending upon whether they've gotten 2 or more, 4 or more, and all correct answers.
The column match table has a second function that it does. Not only does it lay it out horizontally for you on screen, it does it vertically in the tech output so that you don't run off the edge of the column. So it does 2 things for you.
Yeah, a very good point, David. In fact, I have used general column tables a lot in writing problems that have text and graphics so that I can put the text and graphics side by side in HTML. And when the student prints or generates a PDF hard copy, like David said, then it'll be stacked text on top of the graphic instead, which is a very nice feature. And down here in the solution, you'll notice I have harvested from the correct answers. I have harvested a reference to an array. I have promoted it to an actual array of Perl things, and I've given that array a name. Then I've taken those array elements and joined them by comma spaces, and that'll give me a string, which I could print for the student as well in the solution. Now we're getting into something that's, I think, kind of interesting and fun. We got a question that, on the surface of it, seems pretty simple. E to the 7 times x minus 10. And if you submit the correct answer, of course, you need to use the proper parentheses. And it should get marked correct. Now, WeBWorK evaluates student answers numerically. It chooses, if I remember correctly, something like 5 points at random from the domain and evaluates the correct answer and the student answer at those 5 points. And, of course, if they agree at those 5 points, there's a high probability that the student answer is actually equal to the correct answer and should be marked correct. Now, in order to get robust, good answer checking, we need to avoid potential problems that might come about from checking the answers in that method. So one of the potential problems is, of course, numerical instability, right? So if you take the sign of e to the 7x, well, e to the 7x is growing rather quickly, even on the default domain of x between -1 and 1. And so we're plugging some very large or possibly very small numbers into the sine function. And of course, when we plug very large numbers into the sine function is going to oscillate quite rapidly. And so there's the potential that we'll get a bad numerical comparison because the oscillations are happening so quickly. So one option to ameliorate problems like, oh, this was not the oscillation one. Okay, so I guess I should have followed my own hints. Why is 0 marked correct? Well, let's see. On the default domain of -1 to 1, what's happening?
E to the 7x minus 10 is really small.
Yeah, it's very, very close to 0, and sine of 0 is 0. So we are well within the 0 level tolerance. And so this incorrect answer is actually being marked correct. So we'd want to probably change the limits for the domain. That's what the limits means. The domain of answer evaluation. We could also choose to test the answer at particular predetermined points that we specify, A, B, and C. Or we could, in addition to the randomly chosen points, also test at some predetermined points. And we could do this globally for all of the functions that are in the context, or we can do it more locally, like we have here, assigning the particular answer math object some particular test points. We could also increase the number of test points that we use in the answer checking. So let's see, let's take a look at the problem source. And if we instead choose to check answers in the range 5 to 15, we're going to get a much more reliable answer checker. If we increase the number of points that we randomly choose to evaluate this function at, we'll also probably get a more reliable answer checker. Like I said earlier, if we were to uncomment this line right here, we could reset the domain for this one particular answer. And so this scalar $A, if we plug in A there, then we'll get A minus A, which is 0. We'll get E to the 0, which is 1, sine of 1. That's a pretty reasonable thing to be checking near. So if we evaluate this function to the left of A by 2 units and to the right of A by 1 unit, then we're probably sort of hitting the sweet spot for answer checking this particular function. We could do the same sort of thing by having specific test points that we use as the only things to be checked, or we could have not only randomly chosen points, but also predetermined points if we were to uncomment this line right here. And of course, if we were to uncomment all these lines, then only the most recent one would really take effect.
Paul, before you pass by that, the one that you've got highlighted there about test points, you should note that this is an array of arrays, even though the inner array only has one element in it. If you are in a context where you've added variables to it, you need to provide values for every variable in the context, not just the ones in the function, because students are allowed to enter any of the variables in the context. So you need to have values for them to test that. So if you happen to have added an x and a y to your context, your test points have to have 2 values in this inner array, not just one. And even if the function only has x in it, you have to give values for every variable that you have in the context.
Right. So what that would look like would be if you had x and y as the variables in your context, then you would need a comma-separated list for an x value and a y value right here, another x value and a y value right there, and so on. And those, of course, those variables are going to be ordered lexicographically, alphabetically. So you'd specify the x value first and the y value second in each of those pairs of numbers that you'd use to replace what I've highlighted. Okay, and here are the global settings. If we had other functions in the context, then these settings right here, if we were to uncomment these lines of code, these settings would actually kick in and take effect for all the functions in the context. Okay, so there's also the diagnostics flag that you can set in the answer comparison method. And it's very useful. So let's see, I don't want to be there. I want it to be here. Okay, so here's the actual problem. And if we want, let's go ahead and play around with it. I'm going to open the problem source. Okay, so if we wanted to, we could play around with this, and let's do that. So let's type in an answer. Let's type in 0. Okay, and we're getting a warning. Why are we getting a warning? Well, warning messages appear at the top and at the bottom. The warning in this case is a good thing. It's what we expect because we set the diagnostics flag to be true. And David looked at diagnostics a bit last week. So right here, the correct answer, as you can see, is on the order of 10 to the minus 26, or 10 to the minus 21, 10 to the minus 20, and the 0 level tolerance is something like 10 to the minus 12. So the correct answer and this 0 answer that the student entered are actually within the 0 level tolerance. Okay, let's go back to this and go ahead and edit, and let's uncomment that, which will set the domain for answer evaluation to be centered at A and go 2 to the left and 1 to the right of A. And now if we submit answers again, it's now being marked incorrect, which is what we expect. And you can see from the graphs that David has provided us via the diagnostics tools, the student answer, which is 0, is diverging greatly from the correct answer, which is green. And you can see in this table of values, for instance, when x is 7.29, that was some randomly chosen point in the domain we specified. The correct answer is about 0.006. Student answer is 0. And 0.006, which is on the order of 10 to the minus 3, is not within the 0 level tolerance of 10 to the minus 12th of 0. And so the student answer is being marked incorrect for this particular value of x, and as you can see, it's being marked incorrect for the other values of x. That's why these are all red down here. We could also uncomment that and choose more random points for answer evaluation. And if I submit answers again, oh, I got an achievement. 3rd time is a charm, even though I got the answer incorrect. Okay, and as you can see, now we've evaluated this function at 10 points in the domain, and we're still getting it wrong at all 10 points. Are we going to get the correct answer correct if we type in what we're supposed to? Yes, we are getting the correct answer, and you can see that the student answer and the correct answer are on top of each other in this graph. The absolute error is very small. The relative error also is very small, and the relative error is being marked correct at all points. That's why these are all green. Okay. So I think there are other options that you can play around with by commenting and uncommenting various options that I've put in the source file there for you. I'm not sure it's a good use of our time to go through all of those in detail since I've already explained them. Okay, so here's where I'd like you to hit your talk button and let me know what you think is going to be wrong with answer checking in these examples. So let's start with part A.
So doesn't the interval go from like -2 to 2, or will it include 2, so you could have some potentially undefined values as well as above 2 or below 2?
Yes, exactly. So this input to the natural log is going to be positive only when x is outside of the interval from -2 to 2, and the default domain is oh boy, is it -1 to 1 or -2 to 2?
-2 to 2.
-2 to 2. We could have easily checked that by running the diagnostics flag, but so all the points at which this function are defined are outside of the default domain. So we would need to fix that. So if we enter the correct answer and go ahead and submit this answer, let's see what happens. If we get this error, can't generate enough points for comparison, and that's because well, all the random points that were chosen had a problem, that the student answer and the correct answer were undefined there.
So you can see the domain under the first graph, -2 to 2.
Yep.
And so it really could find no points.
Yep. Let's see, let's go to the problem source and take a look at some possible ways to fix that. So for the first answer, you could choose to set the domain locally for that one answer by choosing a better domain. Choosing -10 to 10, it does contain points at which the function is defined, but it also contains points at which the function is not defined. So that's maybe not the best choice. Instead, we could do test at and add some points that are negative and in the domain, and add some points that are positive and that the student is not likely to choose to the domain. We could also up the number of test points as well. So that might be a better solution, to do both of those things: enlarge the domain and also check some points that are negative and positive. Okay, again, part B, who thinks they can identify what's going to go wrong with answer checking the formula e to the 20x?
It's just too large. It's way too large. So the relative error will not be very large.
Exactly. The relative error is not going to be very large because the answer itself is so large for values of x between -2 and 2. And in fact, if we enter a function that is close but not exactly the same as, I think I need one more 0 maybe. Okay, I need one more 0. So you can see if the student had some messy expression here that evaluated to something just a little bit above what they really should have had, which is 20, their answer might be marked correct, and perhaps you want to exclude that possibility. So looking at the source for answer 2, we could address that question by, well, one way would be to shrink down the domain. 0.2 times 20, it's not that large. So e to that value is not going to be too terrible, but there are maybe better ways to do it. As the person who chimed in to talk said, the relative tolerance is not going to be very useful because the answer is so large for typical points in the domain. So instead, we could use an absolute tolerance, which will check that at each point, the student answer and the correct answer are within, I don't know, this is what, 10 to the minus fifth of each other.
Right.
And that will, that may just be better. Okay. In general, I would say try to stick with answers that are going to be between, say, -1 million and 1 million. And if you're starting to get largish, like over 1,000 in absolute value, maybe switch to absolute tolerance. I don't know. Play around with it. There's no one miracle recipe that's going to solve all problems. Sometimes you just have to play around with it.
Paul, can I make another comment while you're on that subject?
Yeah.
If you had something like e to the 20x plus x, the plus x is going to have no effect in the answer checking. So a student could enter e to the 20x. So if you have terms in your answers that are widely different in magnitude, the relative testing is going to be ineffective. So that's another place where instability comes in. If you have really big terms and really small terms, e to the 20x plus e to the minus 20x, those two terms are going to be so different that a student can leave one of them off and still get the right answer.
Yep. Yep. Good point, David. All right, and here's one of my favorite functions, the hyperbolic tangent of x plus 11. So why would answer 1 be marked correct for that? Go ahead and press the talk button.
It's because the hyperbolic tangent function in that interval is going to look like the constant function 1.
Yep. Right, if we graph it using Google, we can see what this function looks like. Oops, that was bad. And you can see that the value of this function is very close to 1, except for values of x that are very close to the origin. So this sigmoidal S-shaped hyperbolic tangent function is pretty flat in a lot of its natural domain. Okay, so to deal with that, we can use a technique we were already familiar with. We can set the limits to be, well, find the center point. In this case, the center point, so to speak, is going to be -c, and then go a little bit to the left of that center, a little bit to the right of that center point, and then you'll actually be hitting the part of the function that's it's got some curve to it. It's not flat. Okay, and there's the actual function if we wanted to play around with it. Okay. So now it's possible to require students to enter answers in specific formats provided by a lot of limited contexts. So the context fraction macro is going to provide a way for us to restrict the type of answers that students are allowed to enter. So, of course, students can enter, if we were just to use plain old math objects, not the context fraction macro, students can, of course, enter decimals and fractions and any combination thereof. And WeBWorK is going to interpret their answer in sensible ways. If you want to limit the type of answers that students are allowed to type in, you can restrict to only fractions. And then there are these limited fraction and limited proper fraction contexts, which restrict the type of fractions that are allowed even more. So in particular, for instance, let's say I wanted to learn more about what this particular context does, and I thought, well, I'll try this pod documentation page. Okay, scrolling down the page, I see the list of appropriate contexts that are provided. And then David Zervone, of course, who wrote this, has provided us with wonderful documentation that says what can and cannot be done. Right, so in this limited fraction context, there are going to be answer checker flags that specify whether students must reduce their fractions fully. And that's going to control the verbosity, or how much error message is displayed to them. Yeah, so then it goes on to document all of the context flags that you can pass to the comparison method. I feel like this is a pretty well documented set of features. Let's go ahead and take a look at the problem source. So with the limited fraction context, for instance, we have some context flags that will either allow or disallow students to enter mixed numbers, right? Like 2.5 could be written as 2.5, where you write 2 space 1 divided by 2. And, that might be great for middle school mathematics, but for college mathematics, you might want to disallow that, and so you can set context flags that are going to control how those things are displayed, whether or not those things are allowed in the first place. So there are lots of options here, and they're all, I think, documented fairly well, so I'm not going to go into detail other than to sort of point out where to get that sort of information and what to do with it, right? So as you saw in the documentation page we visited, there were a number of flags you could set in the comparison method, and those are exhibited here. Now, WeBWorK, of course, is something that's being run on a computer. And the first question on this slide, why does 1.235 minus 1.23 equal 0.00499999999989? That's kind of bizarre, isn't it? Well, when you stop to think about it, the internal processing that goes on in your computer is going to take your decimal representation of the number and convert it to binary, and then do operations in binary on it, and perhaps return some result. So, as a side effect of that conversion process back and forth between decimal and binary, we get some sort of round-off errors that creep in. Okay, so how do we deal with those? I think the best way to deal with those is to take objects and promote them from Perl objects, which is what I have highlighted, to actual math objects, because math objects are smart because David Zervone wrote them. And one of the things they're smart about is dealing with these goofy kinds of answers, right? So let's see what the problem source actually looks like. Okay, so in this particular problem, we are asking the students for a decimal approximation. We're also asking them for a fraction. And so in order to do this problem properly, we've now set up 2 different contexts. And one of the points of misunderstanding or concern earlier was, how do I write a problem with two different contexts? Well, here's an example of such a problem. In the first context, to address part A of the question, we're going to want students to enter a decimal approximation for this number. And instead of using this Perl scalar $A, which is going to have that sort of round-off error in it, we could instead, if we wanted, we could comment this, remove this comment here, and define A as an actual math object, in which case the math object real constructor function is going to take care of that rounding issue for us. Another option that I don't recommend is to try to deal with this round-off error yourself. So one way to deal with it, if you wanted it rounded to 3 decimal places, would be to take that Perl scalar A, multiply it by 1,000, round the result, and then rescale it down by 1,000. A perhaps better option would be to use this low-level Perl function called sprintf to specify that you're going to take that Perl scalar $A, and you're going to format it as a floating point number with a leading 0, a decimal place, and 3 digits beyond the decimal place. Okay, and there are a number of options for sprintf. If you want to know what those options are, you can go to Google and type Perl sprintf, and sprintf is a general utility. It's available in many different programming languages like C and Perl and others. And as you can see, there are different types of numbers you can specify. You could specify a floating point number if you wanted. You could specify that we're rounding to an integer using this %d option in place of the %f that we saw earlier. Back to the source. Okay, so that deals effectively with part A. We will set the answer for part A equal to this real number obtained by promoting this Perl scalar up to a math object using this constructor. Okay, then for part B, we're going to want to restrict the student answer to be a fraction. So we're going to use the fraction no decimals context and require them to enter the answer 1/200 as a fraction. One thing to note in part A is that in order to require students to enter a decimal rather than a fraction, we can undefine some of the operators that they're allowed to enter. So we can undefine division or exponentiation operators using this operators method, which takes the current context. So anytime you see context and then parentheses, that's really referring to the current context, not some new context. And then you're saying modify that context by undefining these particular operations. I think that's pretty self-explanatory. One really cool feature that WeBWorK has is the ability to add named functions to the context. So in particular, you could add a generic function named f to the context and use it in your correct answer, and students can use it in their own answer in some sort of, for instance, a graph translation and scaling problem. Okay, so students could enter the answer y equals f of x minus 5, and that would be marked correct. We can also do the same thing with functions that are, of course, already in the context. So shifting right again. And we can add new named functions, like say you wanted a log base 2 function in the context. You could add that to the context, and then students can use it in their answer as well. And for some reason, whenever I'm typing X, it's not coming through. There we go. Okay, so let's take a look at the problem source. What we're doing is we're using a specific macro called parserFunction.pl. And what this allows you to do is to define new named functions and add them to the context. And once they're in the context, then MathObjects knows about them, and they can use them in answer checking and everything else. Okay, so what did we do to construct these functions that we added to the context? Well, we declared a context. Numeric context has the variable x as a default. Since we're doing a logarithm problem, let's make sure that log is going to be interpreted in the way that we want it. Okay, so the default setting is that log is interpreted as natural log, just like in Perl. Okay, in MathObjects, you can override that behavior and specify that log means base 10 log using this context flag. There's also another way to do that, course-wide, I believe. So if we look at the course configuration menu, there's this PG problem display answer checking tab. And one of the options down here is about using log base 10 instead of base E. And if we were unclear on what that meant, we could click the help and get the help page. I don't want that right now, though. Just wanted to show you how to use it. And on a course-wide basis, you can set this value as you like. Okay. All right. Let's get back on a tangent now that we've been off a tangent. Okay, so the parserFunction.pl macro provides a way to define a new function and add it to the context. So we can define a new function named f by whatever formula we choose. So internally, whenever somebody types f of something, it's going to get evaluated by this messy arctan plus cosine blah 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 formula. Now, I think I've done a good job of choosing a function that is neither even nor odd, and is unlikely that the student is actually going to enter that as the part of their answer in this particular question. Okay, similarly, the log base 2 function I defined here just as a ratio of logs using the change of base formula for logarithms. Of course, I wouldn't have to do that internally. If I wanted to define a function log base 2 that was defined for all x, I could internally evaluate that function as this polynomial, for instance, which is defined for all x. I don't necessarily recommend that, but you could do it, I suppose, if you wanted to. And as you can see, the answer checking, or the answer construction and everything in the rest of the problem is pretty straightforward. One thing I'd like to point out is that I constructed an array of answers, a Perl array, and the first element in that Perl array is this math object. And then I'm going to determine the second element in that array by substitution, right? So once I've randomly chosen either the sine or cosine or e to the x to be the part B, the function that appears in part B, I can then take that math object and substitute an expression in to that function. Okay, notice that I'm using substitute here and not eval. Eval is expecting some sort of expression here that is numeric and will therefore evaluate to a number, whereas substitute is more general and will allow you to substitute in expressions that are not necessarily numeric, they're also algebraic. Okay. As you can see, there's a little comment here. You can do this in a different way. You can substitute the formula G in. It's doing the same thing in a different way. And of course, since we're working with a logarithm, you probably want to avoid problems in the domain. And so right here, I have chosen the center point, which would be negative a, and I've gone half to the left of it and 5 to the right of it. And notice the syntax that I'm using here. I'm using negative space $a. So one of the quirks about Perl is how it can interpret things. So in particular, if you have $a is -1 and you set $b to be negative $a, one thing that Perl might do when interpreting that is to interpret b as $a, which would be, well, the minus is the decrement operator in Perl. So in this case, we might get that b is -2, which is not what we intended. So to counteract that, you can do two things, two or three things. You can be more explicit. Let's go back to the problem source. You can be more explicit about the multiplication. You could write -1 star $a. That would work. You could do negative and then put the $a in parentheses. That's another option that will always work. Another option that always works is, I lost my train of thought. Oh, yeah, the one that we're looking at. To put a space in between the negative and the scalar. Okay, that will ensure that it gets interpreted correctly as the negation of $a rather than apply the decrement operator to a. Okay, and there's nothing else particularly special going on with the answer checking. I would say that whenever you add a function to the context, especially ones that have like a subscript in them, like log base 2, that you should tell students explicitly how they should enter their answer, right? Because some students might think, oh, I know how to subscript in text, so I'll just enter a subscript in my answer, and then the answer checker is going to barf all over that because it doesn't like underscores in the answer. It might interpret it in a different way. So be explicit and tell your students how to enter things.